Okay, question number 7. Now we are given a complex root of a quartic equation. You can see that we have z to the power 4 over here. Okay, so remember, a quartic equation can have all the 4 real parts, or it can have all of its 4 complex roots, okay, or 2 real roots and 2 complex roots. So right now we are given one complex root, okay, which is z equal to 3 iota. Now, if z is 3, like one of the roots is 3 iota, we can quickly say that yes, we have another root, which is minus 3 iota, because they always exist as conjugate pairs. Okay, so that means we have 2 of its roots, and we have to find the 2 remaining roots. Okay, so this means we need to write this quartic equation as a product of 2 quadratic polynomials. Okay, now can you give me the equation which has these 2 roots, these 2 complex roots? Z squared? How did you find that so quickly? Okay, that's quite impressive, Iman. Mashallah, you've done this so quickly. Remember, I told you that if there are 2 roots, one is alpha, the other is beta. Huh? This is x minus alpha into x minus beta. That is your equation. And this can be written as x squared minus alpha plus beta x plus alpha beta. Do you remember this? I have discussed this with you, okay? You can also write it as x minus sum of the roots times x plus product of the roots, okay? So what is the sum of the roots over here, bacho? Quickly. The sum is 0. And what is the product of the roots? It is minus 9 iota square. That makes it equal to 9. Therefore, we can say, yes, the equation z square minus 0z plus 9 equal to 0, or z square plus 9. This is the equation which has these 2 roots, which are 3 iota and minus 3 iota. Now, with the help of this equation, we can find the second quadratic equation. How can I find the second quadratic equation? The second quadratic factor of this given quartic polynomial. Yes? Long division. We'll have to do that long division over here, okay? So let's do that. We know that this is z raised to the power 4 minus 2z cubed plus 14z squared minus 18z. Could I do the synthetic division over here? Huh? Synthetic division is done when you have a linear factor. Okay, so we have here z squared plus 9. So make sure that they are written in descending order. Okay, both of them. Now z squared into z squared gives us z raised to the power 4, and I'll be writing the like terms under each other. So I have minus 2z cubed plus 5z squared minus 18z plus 45. So z squared into minus 2z, that is minus 2z cubed minus 18z. So they are both cancelled. So we have been left with 5z squared plus 45. So here is 5. So this is 5z squared plus 45. Cancelled, cancelled. So that means this into this, they are both quadratic. They are giving us this quartic polynomial. We have already got its 2 roots, which are 3 iota and minus 3 iota. Now we have to solve the second one. So this is going to be z squared minus 2z plus 5. So if you can find the factors easily, go quickly for the quadratic formula. 2 plus minus 4 minus 20 over 2. That is 2 plus minus under root minus 16 over 2. So this z is 2 plus minus 4 iota over 2. So the two roots are 1 plus minus 2 iota. So these are the remaining two complex roots. So that is how you have solved this whole quartic equation. Okay. Now, without wasting any time, I have a question ready for you people from the past papers. Let's try this question. You will like that question, I believe. I am hoping that you will like that question. We have just 9 minutes and I want to complete that within this video. Look at this fifth question, Bacho. Fifth question, very quickly, we'll be doing that together. The fifth question, come on. Now, it says x to the power 4 plus 5x plus a is denoted by p of x. It is given that x square minus x plus 3 is a factor. Find the value of a and factorize p of x completely. Now, this question is more like, yeah, this is unfortunately not a question on complex numbers. This is simply a question on algebraic division. But we can still do that because we haven't done such questions before. Okay, bacho. So I'll be doing that quickly. So this is x is per 4 plus 5x plus a divided by x squared minus x plus 3. Okay. So x squared into x squared, this is x to the power 4, and then I have minus x cube, I have plus 3x squared. So I'm just writing them on a side because you should write the like terms in a column. So we have x cube minus 3x squared plus 5x plus a. So this is going to be plus x cube minus x squared plus 3x. This is minus 2x squared minus 2x plus a. So this is minus 2. Minus 2x squared minus 2x. This was plus here. Okay. And this is minus 6. So this a plus 6 should be 0 because we're given that this x squared minus x plus 3 is a factor. Okay, so this a is going to be equal to 6 because we can have a remainder when you're dividing something with its factor. Okay, so you can do the second part yourself. You can solve both of them. X squared plus x minus 2 equal to 0. One of the quadratic factors, other is x squared minus x plus 3. Okay. This is asking you to state the number of real roots. So what will you do now? Yeah, you'll just find the discriminant. Don't start finding the roots. Okay. So this is b squared is 1 minus 4ac is 8. So this is positive. You will have two real roots from here. And this is 1 minus 12, which is minus 11. It is negative. So there are no real roots from here. So on the whole, this will have, this quartic equation has two real roots. Okay. I was so excited. I thought that I got a question on complex numbers, but this was not.